All right, this is the review for the AMDM Unit 4 test. First thing I just want to say is all the vocabulary terms up here you do need to be familiar with. So make sure that you go through and look those up if for some reason you are not. Down here, question number 1 is simply asking you to look at each of the graphs and compare and contrast them. And basically what they're looking for are a few things here. Graph number A has what we call no association, meaning that all of the points are completely scattered all over the place. They're not going any direction, and they don't look like they have a comparison. Here we are looking at husband's age and wife's age. Now on this one you actually have a strong association. We say that they have a strong association because the points are so clustered tightly together. We also would say that this has a positive direction because as you move from left to right, all of the points are going up. And you could even say that this looks like it is linear, although that's not often asked. This last graph we would say has a moderate association. Unlike the first graph, which had points that were all over the place, although these points aren't as tight together in a line, they are somewhat together and they are all going in the same direction. Now we would say that this is negative since when you move from left to right, the points are going down in a negative direction. So that's how you would kind of compare and contrast the correlation and the spread. So your spread is whether it is no association, strong or moderate, and your correlation is if they are positive, negative, and they're kind of clustered together. So, of those three graphs, it says which one has a cause and effect. And the answer to that particular question there is C has a cause and effect. Now, since the number of hours spent on video games affects the number of hours spent studying. So cause and effect literally means that there is an effect on the second variable. In this example here, if you look back up at the graphs, the middle graph here, husband's age and wife's age, although they have an association with one another, it's not really a cause and effect. How old a husband is doesn't cause his wife to be a certain age, although there may be an association between the two. This leads to our next question, which is just understanding the difference between the two. So an association is when two variables have an association, and the example I used is the example they gave, which was the husband and wife. There's an association. Younger men probably marry women roughly around their same age. Cause and effect is an association, so there is a relationship between the variables, but this is where one variable causes a change in the other variable. So the example C is a good example of cause and effect. Here, the more time you spend on video games, the less time you're spending studying. So that definitely has an effect on each one. Okay, so that's your vocabulary. So now we're going to utilize that vocabulary and go into some of the examples that we have on how to identify and manipulate the numbers. All right, so for this first one here, we want to go ahead and create a table. We're told here about a phone company that offers a flat fee of $3. So that means at 0 hours, I don't use my phone at all, then I'm spending $3. It adds 20 cents for each additional minute that I'm on the phone. So after 1 minute, I've paid the $3 plus I paid 20 cents. So that would be $3.20. And then for 2 minutes, that would be $3.40, and that'll keep going up. So go ahead and pause the video and fill that table in. All right, so here you should have seen that after, like, for example, 5 minutes of talking on the phone, I would have spent $4, and 10 minutes on the phone gives me $5. Now it's asking you if this table has a common difference or a common ratio. All right, so it's asking here, do the values of the table have a common difference or common ratio? In this case, there's a common difference of 20 cents, so we say that's 0.20. That actually tells us that this is a linear function. And so when we go to write a model for this function, what we're going to do is we're going to write that model using a linear function. So going down to C, it says write a recursive. Recursive is when you use the previous value. On a linear function, a recursive model looks like so. A sub O is equal to question mark. So in this case, A sub O is equal to $3. That means the zero term, which we get from our table of values. And then A sub N is equal to A sub N minus 1 plus 0.2. So in that recursive model, well, plus the common difference, I'm sorry, is the general form. So this would be A sub N is equal to A sub N minus 1 plus 0.20, adding 20 cents. So this would be our recursive model. The A sub N minus 1 means you're using your previous term. So now it wants us to write an explicit rule. So for a linear function, the explicit rule is A sub N is equal to A sub O plus D of N, D being your common difference, N is your variable which would represent time. So in this problem, it would be A sub N is equal to $3 plus 20 cents times N. So that would be our explicit. Again, these are vocabulary terms you're going to want to be familiar with. The next question is asking us to use our explicit rule to predict the price of the call after 35 minutes. So all we do there is we want to know what is the value of the call when instead of using the variable n, we substitute in the 35 to represent the 35 minutes. And then this is going to give you that you're going to pay a $10 charge for that particular problem. Now in F, it says what's the longest phone call you can make if you have $12 to spend. So what we're doing in this problem here is our A sub N is actually going to be our $12, the amount that we spend, and we are going to solve for N, our number of minutes. So you do that by subtracting 3, and so 9 is equal to 0.020 divided, and then divide by the 20 cents, and you should get that N is equal to 45 minutes. So what that means is you can make a 45-minute call with your $12, and that is your linear function. All right, so this next question that we're going to look at, if you'll take a moment to read it to yourself, is about reducing the amount of caffeine in your body by 13% as time goes by. So this actually is an example of an exponential function. So the first one we had was linear, which meant it looked like a line, and an exponential function is one that looks like it's, in this case, it's going to be coming down, so there's that slight curve. The first thing they want us to do is to write a function that determines the amount of caffeine in your body after n minutes. This is an example of an explicit function for this particular type of problem. So for an exponential, the form is A sub n is equal to A sub o times r, or times 1 minus r, raised to the t. It's 1 minus r because we are decreasing in value. If it was increasing, then it would be 1 plus r. So the a sub o still represents my initial start value. So a sub n is equal to 34, because that's the original amount of caffeine in my body, times 1 minus 0.13, we always convert our percent to a decimal, raised to t, the amount of time. So that would be your explicit rule. Now down here it wants you to use the rule. They're telling you that you had a Coke at 3 p.m. How much is in your body at 9? We'll assume that's 9 p.m. So you will have had that caffeine in your body for 6 hours. So we want to go ahead and do 34 times 1 minus 0.13 raised to the 6th power for the 6 hours, and we're solving for a sub n. So in this case that would be 14.47 milligrams of caffeine are still in your body. All right, this is the bouncing ball activity. This is one of the first activities that were in this unit. This tells you that, all right, I apologize for that. For the rebound problem, it shouldn't be 1 minus r. It's actually just times the rebound amount, which is 0.45. So this is 0.45 raised to the t. So 0.45 raised to the t, or this should just be your r value, sorry. All right, so down here in this problem, it says using this value, find what it is after the 6th bounce. So your initial value, they're telling you, is 25 feet. So that would be 25 times 0.45 raised to the 6th power, which is 0.21 feet. All right, for this next table, it's asking you to recognize if you think something's linear or exponential. So in this column here, we're going to take the difference of both these two numbers. So it'll be 13.5 minus 4.6, which is 8.9. And then in this column, I'm going to take 13.5 and divide it by 0.46. Now that's equal to 2.93. And I'm going to go all the way down and do that. So if you'll pause the video and fill in that table. All right, once you've filled out the table, you want to look at, do you have a common difference or a common ratio? And what you'll notice is all of them have a common ratio. And we can go ahead and say that this ratio here is 3.0, since all values, if you were to, are very close to 3.0. So in order to write a function for this model, again, it's exponential because it has a common ratio, so that's going to be a sub n is equal to a sub o times r to the t power. So that's going to be a sub n is equal to the initial value, which our initial value was 4.6 to the 3.0 power to x. Now that's an explicit function. If you were to write the recursive, you would do a sub o. All right, so here we're going to just do your diameter, which is 120 times pi. So that is going to give you a value of 376.99. In order to calculate it says here it takes 30 minutes to go around. So since my circumference is 360 point, well, since this Ferris wheel has to go around 360 degrees in 30 minutes, that means that in 1 minute it must go around 12 degrees. So the last part here is about calculating how high the rider is. So at 2 minutes, you know that you've gone 2 times 12, which is 24 degrees. At 5 minutes, you know that you've gone 5 times 12, which is 60 degrees. So the formula is the radius minus the radius cosine the angle times the number of minutes, and then plus the height of the stand. So to finish the problem, for 2 minutes, you would do 60 minus 60 cosine of 24 plus 15, which is 20.19, and then